Welcome to Learning AI Keywords Fast Track, GPU. Today, we'll explore one of the most important pieces of hardware behind modern artificial intelligence. Have you ever wondered why AI models can analyze images or generate text so quickly? The answer often lies in a powerful chip called the GPU. We'll break down what a GPU is. The answer often lies in a powerful chip called the GPU. We'll break down what a GPU is. We'll break down what a GPU is. We'll break down what a GPU is, how it works, and why it's so crucial for AI, all in plain, easy to understand language. Whether you're completely new to tech or just brushing up, this session will give you a solid foundation. Let's dive in. Let's take a moment to map out our journey today. First, we'll answer the big question: what exactly is a GPU? Then, we'll compare it to the CPU, the brain of your computer, to see how they're different. Next, we'll explore why GPUs are so powerful for AI tasks, especially when dealing with huge amounts of data. After that, we'll look at real-life examples like self-driving cars and chatbots. Finally, we'll clear up common misunderstandings and give you tools to test your knowledge. This structure helps you move from curiosity to clarity. Ready to begin with the basics? Let's go. Now let's understand what a GPU really is. Simply put, a GPU, or graphics processing unit, is a special kind of computer chip built to do many things at once. It was originally invented to make video games look amazing by drawing detailed scenes in real time. But here's the cool part: the same skill that renders explosions and shadows in games also powers artificial intelligence. How? Because both involve doing lots of similar math problems simultaneously. Think of a GPU like a factory with thousands of workers, each handling one small task. While one worker might not be super fast, together they complete massive jobs in seconds. In AI, these tasks are calculations that help machines learn from data. So even though it started in gaming, the GPU has become a superstar in AI scientific research and video editing. Let's see how it stacks up against another familiar processor, the CPU. Let's compare two key players, the GPU and the CPU. The CPU, short for central processing unit, is the main brain of your computer. It's great at handling one task at a time, especially if it's complex, like running software or managing system operations. But it only has a few processing units, usually between 4 and 16. Now enter the GPU. A modern GPU can have over 10,000 cores. That means it can split a big problem into tiny pieces and solve them all at once, a technique called parallel computing. So while the CPU might cook one perfect steak, the GPU grills 1,000 burgers in the same time. And here's the important part: they don't compete, they work together. The CPU gives the plan, the GPU carries out the heavy lifting. For example, when training an AI model, the CPU manages the code while the GPU runs the math. It's teamwork at its best. So why does I need this kind of muscle? Let's find out. So why are GPUs so important for AI? Let's think about what AI actually does. At its core, training an AI model means doing enormous amounts of math, especially multiplying large grids of numbers called matrices. These operations are simple, but there are billions of them. Doing them one by one would take forever, but a GPU can do thousands at the same time. Imagine building a Lego castle. The CPU designs the blueprint, but the GPU snaps together 10,000 bricks in seconds. That's the magic. Without GPUs, training a modern AI could take weeks. With them, it takes hours or even minutes. That's why companies like Google and Tesla use giant clusters of GPUs to develop their AI systems. Self-driving cars, for instance, use GPUs to instantly analyze camera feeds and detect pedestrians. Language models like ChatGPT rely on them to process and generate human-like text. The GPU isn't just helpful, it's essential for making AI fast and practical. But not all GPUs are the same. Let's clear up a common confusion. Here's a common misunderstanding. People think GPUs are just for gaming. Yes, they started there, but today, many GPUs aren't connected to monitors at all. They're tucked inside servers and data centers, quietly powering AI breakthroughs. These are called data center GPUs, and they're built differently. Take the NVIDIA A10 or H100. These chips aren't meant to render video games. Instead, they're engineered for nonstop, high-efficiency computation. They handle tasks like training massive language models or simulating climate patterns. And the best part? You don't need to own one. Cloud platforms like Google Colab, AWS, and Microsoft Azure let you rent GPU time online. This means even hobbyists can experiment with AI using powerful hardware for free or low cost. So next time you hear GPU, don't just think of gaming. Think of AI labs, medical research, financial modeling, all powered by the same parallel processing magic. Now, let's see how this applies in real life. Let's bring this to life with some real-world examples. Where do you actually find GPUs making a difference in AI? First, look at your phone. When you unlock it with facial recognition, that's an AI powered by a mobile GPU. It analyzes thousands of pixels in your face and matches them in a flash. Then there's natural language processing, like when you ask Siri or ChatGPT a question. Under the hood, GPUs are crunching through layers of neural networks to understand and respond. Another major area is autonomous vehicles. Companies like Tesla and Waymo equip their cars with powerful GPUs that process video feeds from multiple cameras every millisecond. They identify pedestrians, stop signs, and lane markings, all in real time. Even creative tools are using GPUs. Apps that turn sketches into photorealistic images or generate art from text descriptions rely on GPU speed. These aren't futuristic ideas. They're happening now. And they all depend on the GPU's ability to do massive math fast. Want to try it yourself? Let's explore some hands-on ways to experience GPU-powered AI. Let's pause and put your knowledge to work. Here's a quick challenge. Decide whether each scenario works better on a CPU or a GPU and explain why. First, writing a report in a word processor. This involves typing, formatting, and saving one step after another. That's classic CPU territory. Second, training an AI to tell different dog breeds apart. You're feeding it tens of thousands of photos, each requiring pixel-level math. That's a perfect job for the GPU. Third, streaming a 4,000 video. While playback uses the CPU, decoding the video stream benefits from GPU acceleration. Fourth, playing a spreadsheet game like Excel-based simulations. If it's one calculation at a time, CPU. If it's simulating thousands of outcomes at once, GPU. Try this. Think of 3 more activities and classify them. This helps you internalize the difference between serial and parallel workloads. Remember, GPUs shine when the same operation repeats across large datasets. CPUs rule when logic and order matter most. Got it? Great. Let's review what we've learned so far. Let's review the key points you've learned today. First, a GPU, or graphics processing unit, is a specialized processor designed to handle thousands of simple tasks at once. It was born in gaming but now drives AI innovation. Second, unlike the CPU, which excels at one task at a time, the GPU uses parallel computing to solve big problems by breaking them into tiny pieces. Third, this makes GPUs essential for AI, where models must process massive datasets and perform billions of math operations during training. From recognizing faces to powering chatbots, GPUs make AI fast and practical. Fourth, Not all GPUs are for gamers. Data centers use specialized versions like the NVIDIA A100 for serious AI work. And finally, CPUs and GPUs work together. The CPU manages the workflow, the GPU does the heavy math. Mastering these ideas puts you ahead in understanding how modern AI actually works. Ready for what's next? Congratulations, you've completed the I keywords fast track on GPUs. You now understand what a GPU is, how it differs from a CPU, and why it's the engine behind modern AI. But your journey doesn't stop here. The best way to deepen your knowledge is by trying it yourself. Head over to Google Colab. It's a free online platform where you can run AI code with a real GPU attached. No setup needed. You can also explore beginner courses on machine learning or neural networks to see how GPUs fit into the bigger picture. If you're curious about programming, check out PyTorch or TensorFlow, two popular tools that automatically send math tasks to the GPU. And don't forget to join communities like our Learn McNeelying on Reddit or Discord groups to ask questions and share progress. Every expert started right where you are, curious and ready to learn. Thank you for joining this session. Keep exploring, stay curious, and remember, the future of AI runs on GPUs,